right, let's take a look at problem number 1. A weight of 18,000 pounds is supported on a rectangular base plate that is 9 inches wide and 2 feet long. The base plate rests on a concrete slab. Determine the stress that the base plate exerts on the concrete slab. We're going to be coming up with our answer in both pounds per square inch and pounds per square foot, with a precision of 1 for the pounds per square inch and 1,000 for the pounds per square foot. So let's first sketch what's being described here. We've got a rectangular plate that measures 9 inches by 24 inches. So our sketch here should show us the plate and should be approximately to scale. Doesn't actually matter how thick this is. We're not told, and that's not going to have an impact on the outcome of this. So we want to dimension any distances that are known. So we have 9 inches and 2 feet. We have our applied force of 18,000 pounds acting downward on this plate. And we are interested in the stress. So let's list what we know. We know the width to be 9 inches, and just thinking ahead a couple of steps, I'm going to also convert this into feet. So 9 inches is 0.75 feet. The length of our rectangular cross section here is given at 2 feet, which is 24 inches, and our applied force is known. That's 18,000 pounds. All right. Our unknowns would be the area and the stress. This is what complete work would look like for these sections. We're going to identify what the piece of information is by its abbreviation in a formula. We're going to list any values that are known that we can attach to that with their units, and just try and be really clear and really thorough about what we know and what we don't know. As far as formulas, in order to find our area, we're going to need to use the area formula for a rectangle, which is just length times width. And to find the stress, we're going to use our stress formula of force divided by area. So first, let's find our area. And again, we're going to be looking for our stresses in both pounds per square inch and pounds per square foot. So I'm going to find my area in both terms. Length times width. That's 24 inches times 9 inches. Need to make sure that we are working in like units here. So I've either got to convert my feet into inches or my inches into feet to make sure that I'm not mixing and matching. And 24 times 9 works out to 216 square inches. Now to look at this in feet, I had a length of 2 feet times a width of 0.75 feet, and that area is going to come out to 1.5 square feet. Now for my stress formula, stress equals force divided by area. So I can take my 18,000 pounds of force and set that over my area, 216 square inches. And that's going to come out to a stress of about 83.5 0.33 pounds per square inch. Or if I work through this in pounds per square foot, same formula. Same force divided by my 1.5 square feet, and I come up with a stress of 12,000 pounds per square foot. So I was told to round to a precision of 1 for my pounds per square inch. Doesn't matter here if you write PSI or pounds over square inches. And for B, I had 12,000 PSI. PSF. A complete correct answer here is going to include the units and be rounded to the correct precision. So there is problem number 1.